Hello all, welcome back to yet another video. The problem, let us solve today's lead code daily challenge, and the problem is jump game. You are given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index, or return false otherwise. So we want to find whether we can reach the last index through the given jumps at each position. Let us say the number of jumps are 2, 3, 1, 1 and 4. So we'll be returning true. Why we return true is from starting from this zeroth index, we can take two jumps. Either we can go from 0 to 1, or we can go from 0 to 2. So let us take one jump from 0 to 1. If I take a one jump, then I can go three steps. I can have a three jump. Either I can go from 1 plus 2, 1 to 2, or I can go from 1 to 3, or I can go from 1 to 4. And you can see that I have reached the last index by taking three jump, so that I am returning true. Let us say we can have let us say we are having a only one jump here. So what I will be doing is we can take either two steps at zeroth index. Either we can go from 0 to 1 or 0 to 2. So let us say we are going to go from 0 to 1. So in the first index I am having only one jump left. Again, so I can go only to 1 to 2. So I will be going here, and we will be going from 2 to 3, since we are having only one jump. And again 3 to 4 we will be having only one jump. So we will be going to the last index also. Here also we will be reaching the last index. So we return true. So let us consider here, actually we are having a 0 steps in second index. So we can take two positions from 0 to 1 or 0 to 2. Let us say we are going to take two steps from 0 to 2, and there is only 0 steps in second index, so we cannot go forward. And similarly we can try to go one step from 0th index. So we will be reaching here 1, and here there are only one jump that we can do. So from here we cannot we can go to second index, but again there is a block. We don't have any number of jumps here, so we cannot reach the last index in this case. So this is an example for false. So let us say we are having let us say we are having a 2 here. So what we can do is, one possible solution we will be returning true here. One possible solution is we can take a one jump and we can reach 0 to 1, and we can take a two jump and we will be reaching 3, and again we will be taking a one jump and we will be reaching 4. So hope you understand this. And let us try out greedily. How we can do in this problem greedily is always taking a long jump, so that we will be trying we'll be seeing whether we have reached the last index. But by greedy approach in the sense, we will be taking the maximal jump at every step, uh, and we will be seeing whether we have reached the last index. So let us say we are having some array given like this. We are having a 2 jump, then a 3 jump, then a 1 jump, then a 0 jump, then a 4 jump, then a 0 jump, sorry, then a 1 jump, then a 1 jump, then a 1 jump, and let us say, sorry, let us say we are having a 2 jump here, and let us say we are having a 0 jump here, and we are having a 3 jump here. So given this array, I will prove that why we cannot take a greedy approach. So if we are having this array, what we can do is, we want to reach the last index. To reach the last index, we will be tending to take the maximum jump that we can take at that particular index. So from 0th index, we will be going to the second index by taking two jumps, and in two jump will be in second index there is only one jump, and we will be reaching this third index, and there is no jumps here, so we will be not reaching the last index. So this greedy approach is not working. Or even we can have a 1 here, and if we have reached here, we will be going to this position, and we are having a 4 jump, and we will be tending to take the largest jump, and we will be reaching here 0, and here also we cannot reach. From here also you cannot reach the last index, and therefore this greedy approach does not work. So if the greedy approach is not working, then obviously we can think of all possible solutions. If we are going for all possible solutions itself, there will be a recursive approach. So let us solve this problem by using a recursive way. So how can we solve this recursive solution is, let us say we are going to give the nums array. I'm going to define a function solve. This is going to be the recursive function that I'm saying to return true or false, and this is going to be a bool. So this function I will be passing the nums, and I am also going to pass the 0th index, and I'm going to say whether I can reach the last index from this function. So this is going to return me true or false. So for each and every recursive call, I can go that many number of jumps in that ith position. So if the nums of I is the number of jumps that I can take at ith position, number of jumps at ith position. So this is nothing but the number of jumps that I can take at the ith position. So I is going to start from 0. So from that 0, what I'm going to do is I'm going to run a for loop. Inside the recursive function, I'm going to run a for loop. Let us say int jumps is equals to, I can take a 1 jump till jumps is lesser than or equals to this nums of I. Till that I can have this for loop, and I will be having the recursive function. How it is going to go is, I am going to call this recursive function again solve nums, and I will be added with this jumps. So if this recursive function is going to return me true, also I'm going to return true, or else at the end of the day I'm going to return false if nobody is returning me true. So by this will be the recurrence relation, a recursive solution structure. So we can try to code the approach. So what I'm trying to do is, for each and every position, I'm going to try out the number of jumps. I'm going to have a for loop, and I'm going to try out all the number of jumps. Either I can take a 1 jump or 2 jump or 3 jump or and so on. So I will be going in serving through all possible solutions and trying to find whether I can reach the last index. If at any point in time, if I'm reaching the last index, then I will be returning true, so that I will be breaking the other recursive calls by returning a true. So this is what the structure of the code looks like, and let us write the code. It is going to start from 0th index. So this is going to be bool and solve, and the parameters are vector int, ampersand nums, and int I. Super. So what will be the base condition? If my I is greater than or equal to nums dot size minus 1, if I am able to reach the last index itself, then I will be returning a true. That's it, as simple as that. So this will be my base case. Now what I will be doing is, I will be running a for loop int jumps, starting from 1 jump, 2 jump, 3 jumps, and so on. Jump is less than or equal to nums of I and jumps plus plus. and I will be calling this function solve with nums and I plus the chums. If this is returning me a true, I will be just returning a true, else I will be returning false. It is as simple as that. This will be the recursive code. So let us run the code. Superb, it gets accepted. But this time complexity will be exponential. It is very larger. So what are the states here? There is only one parameter that is changing, which is I. So we can have one-dimensional DP. Since the without memoization, this recursion is going to be exponential. The time complexity will be 2 power n, and space complexity will be r of n. So we can do memoization using one-dimensional DP of size n, and we can initialize everything with -1, and we can take the size as per nums size, and we can also pass this dp here, and here also dp, which is a vector of int dp here, and we can have the condition here. If my dp is already solved, dp of I is not equal to -1, then return dp of I, and we can also memorize the solution here. Dp of I equals to false, and here also dp of I equals to true. Now let us try to run our code. I think we don't want to have here, we can just directly run. Super great, it gets accepted. Now let us submit our code. Now let us submit our code. Great, it gets accepted. So the time complexity for the solution will be an order of n into the order of n, which is order of n square. We are having a for loop here, and we are also having an index which goes till n. So this solution will be an order of n square, and space complexity is an order of n. So let us try to do a next space optimization approach, which is we can eliminate the auxiliary stack space that is taken by this recursive code. So how can we do how can we eliminate this auxiliary stack space? We can actually initialize everything to be 0, and what we can do is we can run a for loop. Since I is going from 0 to n, now it is going to go for in opposite manner, which is n to 0. So we can have int I equals to n minus 1, I greater than or equals to 0, I minus minus, and we can just copy paste this recurrence relation. So just copy paste after this code. Then what we can do is we can run a for loop here, and this is nothing but solve. Actually, how can we do a tabulation? Here we are running a for loop here, another for loop here, and we can store this in a flag variable. Let us say int flag equals to dp of I plus jumps, and we can have this as like this. Int flag can be false initially. So if there is a true, then this flag will set true, and after this for loop we will be setting this dp of I to be this flag variable, and at the end of the day we are going to return dp of 0. and by this we can just take this code, take this recursive code. Now this code is just modified into tabulation, and we need to add a base condition. The base condition is nothing but dp of n minus 1 is going to be true initially, because that is the base condition that we had in our recursive solution. So we can say it as dp of n minus 1 to be 1. So now let us try to run our code. Actually n minus 2, we can start from n minus 2. And what is the runtime error here we get? Yeah, it gets accepted. Let us try to submit our code. Before that, actually I'm checking whether we will get some error. We can also have a check here. If my I plus jumps is lesser than n alone, I'm going to go inside this for loop. Now let us run our code. Yeah, it gets accepted. Now let us submit the code. Okay, there is a time limit exceeded. Why there is a time limit exceeded is for each and every time, even if this flag is set to true, we can break out of this loop and come, so that we don't want to go for each and every jump and check. So what we can do is, if my flag is true, then we can just break out of this loop and come outside. Now let us try to run the code. So when we submit this code, it should get accepted, because this is not going to give us time limit exceeder. Yeah, great, it gets accepted. So we have converted this into a tabulation method, and this time complexity will be order of n square, and the space complexity will be an order of n. So that's it for this video, and hope you like this both recursive solution as well as the tabulation solution. Let me know in the comments, and if there are any suggestions, let me know. So let us see in tomorrow's LeetCode edition, and until then, bye.